Welcome to the third episode of Innosphere. I am Supan Gupta, one of the associate heads of C5, IITM Madras. To continue our talks over entrepreneurship and innovation, we have Inbound Aerospace, Arctus Aerospace from Nirmaan, and we have Team Anveshak from Center for Innovation, IITM Madras. So today we have two of the startups and one of the competition teams from Center for Innovation. So let's start by introducing them and why did they created that, why did they thought of the idea, how did they join the team. So let's first go to Shivurna.
Yeah, sure, Supan. My name is Shripurna. I am the founder and CEO of Arctus Aerospace. We at Arctus Aerospace, we build sixth generation unmanned fighter jets for defense and combat purposes. Why I started this was I am right now in my final semester. I think there's 10 more days before I am graduating out of here. And as part of Aero Club here, I was part of a lot of projects and like I was interested in the drone space in general. And I think post COVID, I was the first, me and a couple of my friends, we were the first core team of Aero Club. So we had to resurrect the Aero Club from scratch. And doing that, we had a lot of learning experience, and I also got a lot of exposure to the industry, and realized that there is a gap in the market which we can cater to by building an innovative product. And that's the start of my journey. And since then, I have been part of Nirmaan and have been building out of Nirmaan since then.
Great.
Yeah.
Okay.
Hi, I am Arvind. So I am a recent PhD graduate from the Aerospace Department of IIT Madras. I worked on liquid rocket engines for my PhD. During the PhD, I was also involved, associated with the microgravity drop tower that we have at our lab, which is the NCC at National Center for Combustion Research and Development. So this is where the current idea, it became like of looking at how getting a platform for long duration microgravity experiments, exploring that idea took it to the current form of this startup. So startup, we are actually building currently Inbound Aerospace, where we are building recoverable satellites for customers to do in-orbit testing and technology demonstrations, microgravity research, or in-space manufacturing of products that have use cases back on Earth. Before joining the PhD program, I was also involved in a project with ISRO, where we had worked on the air-breathing hypersonic scramjet experiment, which was successfully flight tested on August 2016. So it's a mix of hypersonic background and microgravity that made me into this project.
Great. So next we have Team Anveshak. So let's start by introducing them.
Hello guys, my name is Kaushikan. I'm in the second year. From mechanical department. So when I first came to institute after 2 years of JEE preparation, I was mentally exhausted. So when I first came here, I didn't want to continue the trend of just studying for the quiz writing. So that's when I decided to look out for other extracurricular activities. And one day I attended C5 orientation. That's when I got to know about Team Anveshak. I had a little interest over space research and exploration. So, and I came to know that Anveshak could be one platform where I can actually practice my interest. So I joined the mechanical module of Anveshak because I'm also studying mechanical. So I thought it might actually help me. And being more interested towards the gear systems, I decided to join the mechanical arm part of the rover, which we call the manipulator. So I've learned a lot about additive manufacturing and CNCing, milling, slotting over a period of 1 year in Anveshak. And right now we're trying to make our own gearbox, trying to patent it as well, and hopefully we'll get it done by this July.
Hello, my name is Anuj Srinivasan. I'm also from Team Anveshak and from the mechanical department of IIT Madras. I am in my second year, but currently in my summer break right now, which just ended. Thank God. Uh, so my portion in Team Anveshak is basically in the electronics and software module. So more specifically, what I do is I try and take care of the power requirements of the rover, like batteries and monitor the state of the batteries, stuff like that.
Let's go to the innovation part of this, starting from Shripurna. So before going to innovation part, just tell me one thing. Since I know you personally, so you are from civil department, and you are much more interested in the aerospace. So how come that thing happened? So let's come over that.
So yeah, interesting story. But I, since my school days, was interested in, planes and stuff.
Hmm.
And I had built my first drone, a quadcopter, when I was in
Oh.
6th grade in
Yeah.
school. So
As a
that,
mini project or something?
huh?
As
It was just a project. My house is near NIT Surathkal.
Oh.
So I used to go there.
Uh-huh.
And there used to be the aero club over there used to build this. And since I was a localite, I would go inside and like
Oh.
explore and uh, learned a lot of stuff there and got interested in the core tech there. And after that, I participated in a lot of competition during my school days itself, where I went to IIT BHU, IIT Kharagpur, and there I got exposed to a lot of the intricacies of aerospace engineering, how aeroplanes work, the structural engineering, all of that subsections in an airplane, and it was like too fascinating for me. Like imagine 100 years back, it would have been magic to like have people fly in a metal tube which you built, which will be flying at 35,000 feet. If you tell it to a guy 200 years back, he'll think you're talking about God. So
He'll think
like
you are
engineering is something that like that captivated me, and from there I came here, wrote J basically.
Okay.
Missed aerospace department by some few marks. Yeah, barely. That's why I got civil after that. I did not want to do chemical.
That was my second question, to be honest. Why did you choose civil? Anyways,
Yeah.
so
So yeah,
okay.
got civil, but it turned up a blessing in disguise. A lot of flexibility in civil engineering. I would say a very underrated department. If you want to
Okay.
explore a lot of stuff, civil is actually a good department to be in. I use the spare time, the unallotted credits, and all of that to explore my passion, which was aerospace. And in the meantime, I also had done a startup before, which was in the crypto domain.
Uh-huh.
So I had built a mutual fund kind of app for crypto,
Okay.
which then I sold it.
Oh.
And then with that money, I decided to start this startup. So, that has been the journey.
Coming to the innovation part, so tell me about what exactly is the innovative part that you are trying to do.
Okay, so basically, if you look at the market right now in India, nobody other than DRDO, nobody has been able to in the private sector manufacture a medium altitude, long endurance drone. These are called MALE UAVs. DRDO had a program for it called Tapas, and it started out with Rustam as a program in 2005, and they scrapped it. They started a new program called Tapas, but the major issue was it was basically like Lego. They would import parts and then assemble it here.
Oh,
They
okay.
did some, they did have innovation on the telemetry communication side and some material side, but the core engineering, which is the flight computer, the flight dynamics, the quantitative requirements which are required, none of them were cleared. And even the Tapas program, it ended like 6 months back because they were the the product which they got was never properly indigenous. The
Okay.
propulsion system was imported. The the satellite communication module was imported. A lot of it was imported. So this led me, to see like why is it happening? Why is DRDO not being able to focus? It had a lot of reasons of its own. Let's not get into that. There are since it's a PSU, it had a lot of bureaucracy in it.
That is
And in, the,
let
and in the private sector, a lot of drone manufacturers are majorly building on an individual level, like a quadcopter, which a Jawan can carry in his bag, go go when he is out on patrolling, and then remove it, keep it out, and fly. Now, this is great, but it does not provide combat capabilities. And right now, if you look at warfare around the world, it is majorly being done by autonomous systems, majorly UAVs.
Okay.
America is able to take off a Sea Guardian drone from Texas, fly it all the way to Afghanistan or the Middle East,
And
do their surveillance and bombing, and come back.
sure.
And not only that, Indian Army knows this. The Indian Defense Forces knows this. Navy has been leasing the Predator drone for the past 5 years, and we are also buying these drones from America for $100 million a piece.
100
These
million.
drones cost 30 million to manufacture. These drones are 15 years old. They don't come with combat capabilities. They come with restrictions in where we can operate it. So basically in the Aksai region or in the POK, we can't operate it.
Correct.
It comes with the handstand. So that means that there is a demand for it, and we need to come up with our own, innovations to build the, application side of it. So the drones which you're buying from America have a wingspan of 25 meters. Now, what do we really need 25 meters of wingspan to have the features of what the features it gives? No, we can have all those features at a smaller wingspan as well.
Mm-hmm.
And that is what I'm building for. I'm looking at the features it has and how can we alternatively manufacture it indigenously here.
Hmm.
So right now, if you look at it, aerospace grade carbon fiber isn't available in India.
Okay.
We saw a weaving technique and then we came up with a new resin formula which can help us manufacture with the same features of the imported aerospace grade carbon fiber.
Mm-hmm.
So on similar grounds, we are looking at other technologies, like how can we achieve the features which these imported technology gives, but with the materials we have at home, and then we make it advanced. Then we work on it and improve it. We start from what we have, take off the shelf items, modify it,
Hmm.
which are manufactured indigenously. That is the approach I'm taking right now.
Okay.
That is the one way I feel we can indigenize things without having to start from scratch wholly. So that is
Correct.
that is how we approach innovation in our company.
Okay. So next we have team Anveshak. So before coming to why you joined the team and what do you do, tell me about how was Anveshak started. So can we have a look over it?
Okay. Anveshak was started in 2016. Like back then, the space research and exploration was kind of like under explored in this institute. So it was found by a group of people who were curious about that. Ever since like 2016, we barely managed to qualify for the European Rover Challenge. Ever since that, we've won first place and second places in the International Rover Challenge, which happens in India. Like almost 30 countries from all over the world take part in it. We bagged the first place in 2019, and in 2022 we bagged the second place. We also participate in other competitions like University Rover Challenge and Anatolian Rover Challenge. This year we are also participating in ISRO Robotic Challenge, which will happen in Bangalore. So if everything goes well, we'll have an opportunity to send our rover to space as well. So uh, this team was basically found by a group of students who are very interested in space robotics. We've from starting from using linear actuators for movement of arm, we've made our own gear sets as well. We made a lot of improvisations in the past 7 years. We built over almost 7 rovers. And the 8th rover we are doing right now with features of steering as well.
Okay. Great. Do you want to add something? Okay. So okay. So coming to that, following up that, there have been many teams, universities that have been participating in these competitions. So could you tell me about what is your unique features over them, or what are your major achievements that you have done through the past 7 6 6 7 years? Okay.
Okay, one major thing we have other over is the technical superiority.
Hmm.
We have very nice mechanical framework for the rover as well as the electrical framework. Line of sight communications can go up to 2 kilometers, and we have like
Oh. Okay.
advanced mechanical systems. We make use of rocker bogie, which can climb up terrain up to 50 degrees. It's pretty huge for a rover, provided that the electronic box has to be stable. And based on these features, we're trying to improvise the places where we can use our rovers. Rovers can not just be used in Mars; they can also be used in places where humans cannot go. That is part of like the point of like the basic idea. So it can be used in like maybe the nuclear plants. Robotic arms you can see as will be used in supply lines industries everywhere. Our arms make use of advanced gear systems which we made ourselves. It has like very high efficiency of 95 percentage. So all of that cumulatively make our rover like really good.
Oh, great. Okay, so let's walk towards Arvind sir. So before coming to your startup, just I wanted to personally know this thing that since you have been doing PhD, and so how do you feel being around BTechs and doing a startup rather than people
Yeah,
who
it's
go about maybe professors or more research oriented fields?
okay. In that way, I'm like an outlier even in the lab. Most PhDs get into either
Hmm.
postdocs or get into jobs. Very few get into startups. So that was a challenge.
Hmm.
And coming to like working with BTechs, actually you get a different perspective with respect to them. Like they are very active, that kind of thing.
Hmm.
And I would also like to become active like that, man. That much
Okay.
energy, you can say.
Okay, that's really good.
Yeah.
So so coming to your startup, so can you?
Innovation. As I said, we are building a recoverable satellite. So it's a satellite that can come back. So it'll go in a launch vehicle to an orbit. So once the launch vehicle company injects it into an orbit, it facilitates customer payloads to do whatever they want to do. It could be either testing a subsystem payload or something, or should do some microgravity research experiment or something. So once it is over, we'll actually bring it back. So the way we bring it back is actually the way the new thing that we are bringing. We are actually taking advantage of what is called as lifting body technology. So it's actually a vehicle that actually glides back, but there is no wings in it. So the body itself will actually creates the lift to sustain for the gliding motion through the atmosphere while coming back. So and in addition to that, we also it's able to maneuver itself and land autonomously on a runway. So you actually are mixing between lifting body technology and autonomous landing kind of a technology, you can say. And then in addition to that, we are basically taking advantage of the small scale of operation. So the entire thing is actually a smaller scale. So we can actually take advantage of a large number of available launch vehicles. So to choose from the cheapest launch vehicle. So launch vehicles come in two major, you can say one could be ride share option, which is provided by the larger launch vehicles, or one could be a dedicated launch, which is by small launch vehicles. So small launch vehicles the advantage with them is you can actually launch on demand whenever for the customer alone. So if the customer wants to launch it on a particular time to a particular region, we can actually take advantage of that and then book a small launch vehicle and go to orbit at the orbit that the customer wants, and then do the experiment and come back. So because we are actually on a smaller scale, we can also do what is called as return on demand. So that is something which is not being explored currently. So that is what we are actually offering.
Okay, so any specific experiments that you're focusing on?
It could be anything. So we are just like a platform provider. We will just provide the electrical interface and communication interface for the payload. So initially we are looking at spacecraft hardware that needs to be qualified in space. That is the first market that we are looking into. So all these small satellite companies are building some hardware that has to eventually fly in space. So instead of having a demo mission, you just put the payload or sensor in our payload volume, and then you can test that. So and then you can bring it back also to do post-flight analysis, and even refly possibility is also option. So this is something that we are bringing. So we are actually bringing what is norm for the airborne flight testing. You fly, you test, then you come back, you evaluate, and then you can even do a reflight. So that kind of a iterative and flexibility we are bringing to the space domain.
What will be your future plans?
So this is just the initial market that we are looking. This microgravity in orbit testing. We want to go big, grow big also, and in terms of going into a cargo transport to an orbiting destination. It could be International Space Station or some other private space station. So the technology is the same. So we are actually just maturing it in a smaller scale. It's just that we even have some of the bio payloads actually could also be flown in our payload volume. So we also have a small scale environment control module. So it is actually, the technology is the same for, if you can scale it up, you can actually go into a crew version. So it's a human. So we'll actually have a complete range of small scale for the microgravity experience, cargo transport to an orbiting destination, or crew transport to an orbiting destination, or space tourism. It could be either. So that complete range is what we are looking into.
Great, that's a very wide range, to be honest. Okay, anything else you want to do?
Yeah, I think this is the right time for us to do it, because even in Indian context, it is announced that the Indian space station is also announced. So we want to be a part of it. Actually, we want to be the first guys doing it.
Really,
private
really
players
great.
doing it.
Okay, so let's go to Shipurna. So tell me about your future plans. What are you, once you build it up, then how are you going to go about it after it? After a certain point of time.
Yeah. So basically, we have set us, a milestone for the next, 6 month, 1 year, and 2 year milestones.
Okay.
We are working towards that. So right now, we do have a prototype, a scaled down 1:5 scale prototype. So right now, the wingspan is 2 meters.
Okay.
So we have tested that. It's electric. The next step would be to scale it up, make it into 4-meter wingspan, integrate IC engines into it, and get our hands dirty with that. Develop the technology one by one, and keep scaling up, because when when we scale from from 2 meters to 4 meters, a lot of things come into play. You'll have the sh- the material behave differently,
Yes.
the wing loading, the propulsion.
Yeah, it's a
There are a
very
lot of stuff which comes into play, and we learn on the go. So I personally believe like move fast, break things. It also applies for hardware as well, because if you don't crash a plane, then you'll not learn what went wrong. So that is the approach we want to take. Also, on the simultaneously on the autonomous flight and AI integration part, we are looking at how can we equip an ordinary Jawan
Hmm.
to be onboarded into this platform easily.
Okay.
Because right now, if you look at it, we'll have to get specialized people who know how to operate these complex systems.
Hmm.
They'll have their own code which they run in, how to operate the system, they'll have their own operating systems, and the layout of the remote piloting platform
Hmm.
is complicated, which is very, and it seems redundant right now, because they are looking at data which is being collected from the drones,
Hmm.
and they're making decisions while they're analyzing the data and making decisions, while we can have a computer analyze, make decisions on behalf of like gain inferences from the data, and then let the human make the final decision. So like that's where machine learning and other stuff come into play. We are also working on that end and integrating that into a single stack flight computer.
Oh.
So we want to build that as well. So while the hardware side of it is scaling up, the software side of it is building it and then making it cyber secure, because cyber
Yeah.
security is also a very big part of it, and there are a lot of
Correct.
military standards we'll have to follow,
Correct.
and they have their own requirements of how much encrypted and all of that stuff. We have to maintain that and go forward.
Okay.
So yeah, that's the plan. 6 months we'll have our next prototype ready,
Hmm.
which will be around 4 meters, which will, I think it will be in December of this year basically.
Okay.
And then December next year we are looking to scale it again to 8 meters.
Okay. So where do this end? To be honest.
This ends at 10 meters. So
Okay.
because that is a small market we want to target right now,
Hmm.
but the long-term vision is fighter jets are going to be redundant, human-powered fighter jets, where you'll have a human seat, because
Yeah.
humans have a limit on how many G forces they can take.
Correct.
If you look at the US right now, if you look at Turkey, everyone's working on next generation fighter jet. Meanwhile, India is still working with its LCA Tejas. Now that's great. We have built a great platform. We'll also have to work on, like, we have to look 10 years down the line, 20 years down the line, look at the warfare being conducted then, and we have to start building for it right now. So
Correct.
that by the time 20 years down the line, we have the platform ready and we are ready to like
Face any situation.
face any issue we have. So
Okay.
America right now has this company called Anduril.
Hmm.
They are also building in the same space we are right now, which is like advanced air platforms. They are also working on a platform called Fury, and we want to do that, but in India.
Great.
That's what we want to do.
Okay. So really good vision, to be honest, thinking about 20 years down the line. Okay, coming to Anveshak, so is, I mean, what are your future plans for the team? If I ask you in general, like right now you are participating in competitions, so how will you make sure that your rover actually goes to Mars?
Okay, so what we are building right now is actually just a prototype.
Hmm.
So if you, for example, the most part of the rover right now is made of aluminium or
Hmm.
ABS when it comes to some parts of the arm.
Mm-hmm.
So when it comes to an actual rover, it's gonna be like way costlier. Wheels are gonna be made of titanium. Body is gonna be made of materials that can be exposed to the type of atmosphere it's gonna be in. So right now we are participating in IROC, which will happen in few more months. So our goal is to design a rover and win it in that challenge, so that we'll have a possibility of collaborating with ISRO and maybe even sending our rover to Mars sometime in the future. Um, at this point, we also have collaborations with some companies which provide us PCBs, but we also plan to use our rover and um, industries like the nuclear ones, Keel Park Industries. So those are the goals for us right now.
Great. Okay, so okay, I'll ask you follow up for that. Say any major challenges that you think, okay, it could have been solved, but some issue popped up. randomly or okay, as a journey while you were participating in competitions, what were the major challenges that you faced?
Okay, one challenge that comes to my mind. In 2019, we had to go to USA for the University Rover Challenge.
Hmm.
So it was not a technical issue. We had to carry all our electronic stuff part by part,
Mhm.
and you know how airport handles stuff. So we broke our PCBs and our drive system
Oh.
did not really work. So
Mhm.
it was one thing.
So how did you participate in competition after that, or what happened
Okay,
after
yeah. Our rower ran with two wheels, so we did not really win that competition.
that? That is of course, but great. At least you handled it. Okay. So pretty similar question to you as well. What are the major challenges that you're facing right now, and which you might face in the future? That is something that you are
Look,
not able to figure out as in
yeah.
right now. I mean, there are pretty set of challenges that you know. Okay, I'll figure this out. There are set of challenges that you know. Okay, I don't really know how to figure that out.
Yeah, I mean, there are a lot of problems already right now when
Okay.
you're starting out. A lot of questions which,
Hmm.
we'll figure out on the way. We'll
Hmm.
do that. That's what they say, like, ignorance is bliss. You'll figure out something. Kuch to kar lenge, that attitude. So, uh, like, I mean, short term, we have to stay alive. The company has to stay alive.
Okay.
So
Hmm.
ensuring that the money in the bank doesn't run out. Looking at, like, that's from an operational perspective. I'm telling. From
Okay.
technical perspective as well, there are a lot of problems. But I have been speaking about technical.
Okay. Even if I ask you about the operational or the business part of it,
Yeah. So
so
look,
maybe.
this is a very capital intensive project.
Hmm.
I mean, even for Aravind, it's the same case. It's going to
Hmm.
be a very capital intensive project, and you have to look at how are you going to pay your bills, how are you going to ensure that month end your employees get the money, and
Correct.
like you have money to buy hardware and build hardware. That is very important. So staying alive, getting the investment, getting seeing if there are any projects we can work on along the way in the same domain.
Hmm.
This is very hard, and the sector also is very hard because this sector is primarily known not to be fast moving. Defense procurement has been, now they're gathering pace because of privatization and a lot of
Yeah.
support for startups.
So that question also, is there any restriction from like the defense part that is I'll say in a layman language paining you too much?
Uh, Look, operating with the government is
Yeah.
quite a pain,
Yeah.
but it is much easier now than it has been in the history.
Great.
It has been more open right now. They're more open to ideas. The fact that they're allowing startups, they have a program for startups itself
Mm-hmm.
called IDEX,
Mm-hmm.
is a big, like a testament to that. They're working towards
Some
opening up the industry slowly
to the
to
private.
startups, to new players who can build this stuff.
Great.
Because right now everything has been, they had their own factories. The army used to operate their own factories, and it used to be very inefficient. And like, I'm forgetting the name. There are a lot of factories across the country where they manufacture, from artillery shells,
Mm.
artillery shells to
Mm.
weapons and all of that. Like, it's a they are now slowly divesting, and they're slowly moving towards privatizing and ensuring
Mm-hmm.
innovation comes in there, and that it's looking good. Things are looking good. There is pain,
But
but
we'll
things are
handle.
looking good. Yeah, we can figure it out.
Okay, great. Okay, so some similar question to you as well. What are the major challenges that you're facing as of now, and maybe in the future as well?
Currently, so we are within the IITM Nirmaan pre-incubation program.
Hmm.
So that means we are not registered. So that also means that we cannot take full-time employees because of the lack of funds that we have here. And so keeping the interns motivated throughout is actually a challenge that we are currently facing. And then getting more interns also. We currently have a launch team, but still more is needed for different verticals. And then keeping them motivated, I would say it'd be a challenge.
Mm-hmm.
And then in the long term, so in terms of Indian context, regulations would be a major hurdle because there is a lot of work that needs to be done in that.
Mm-hmm.
If you look at US, there's already a standard framework for getting for example, like the way we get a launch license,
Uh-huh.
we need to get a re-entry license that the spacecraft has to
Okay.
come back and land because you are using
Makes
the
sense.
country's airspace and land. So this is not similar to the Gaganyaan mission because they are landing in international waters. So just a no-fly zone would do. But here actually you have to simultaneously work with the aviation authority, which is in our case it's a DGCA. So because you are using the country's airspace to land back. So it is actually you have to coordinate with the airspace where the airplanes are flying, along with the ISRO. I mean,
ISRO,
space,
yeah, the space
in
organizations.
space anything. So that kind of guideline.
It's
needs to
basically
be
creating a new sphere of
new sphere actually,
new
because,
sphere of like regulations and
yeah. So we had actually spoken with some of the DGCA guys here.
Guidelines.
So they said it is like they are not proactive. So they, as and when this comes up, they will actually look at other countries how they are doing it, and then take it. Similar was the case for the you can say urban aerial mobility vehicles, VTOL, eVTOLs. Similar was the similar case. When startups started building similar kind of products, then they looked at how ESA and FAA are doing it. So
correct.
currently we are actually following the FAA guidelines, which is more standard, but we want to bring that kind of thing in the Indian context.
Correct. How about you two having some common?
Yeah, there is actually something that we actually have common in it is the autonomous of that. So
Okay.
autonomous thing. So our vehicles, also, but ours is more conservative because we just need to follow a trajectory. He actually has to more dynamic.
Yeah.
Real-time decisions need to be more. So it's like more intelligent for him, like lesser intelligent version of the actual product.
In his case, there will be a lot of re-entry physics and all of that coming in. For us, it's majorly we're staying in the atmosphere, not going outside the atmosphere.
And in a compact environment, could be anything. It could be evolve into any area. So it's
Yeah.
more challenging.
And when you go into supersonic speed,
Yeah.
there's the aerodynamics changes. Like when you expect the air to compress, it expands.
So with respect to our case, we just need to be within our bounds. That's all. So within the bounds of the whatever it could be deceleration loads or heating loads.
Yeah.
The trajectory needs to be like that.
I mean that we had a lot of discussion on autonomous landing and
Yeah.
stuff.
So that is one thing that we are looking at. So maybe if at all we could get out like our autonomous that application as a standalone offering, it could be one thing that.
Yeah.
So a similar question to you. If I have zero idea about ISRO. I have zero idea about space. I have zero idea about it. So how do I start it, and how do I join Team Anveshak, or how do I get into this kind of field?
I mean, if you have zero idea, I mean, then first thing to do if you want to join anything is just research on it, right? So you have to research on it, you have to figure out everything. I'll go into the specific parts, I am not good at general answers. So if you want to come to an IIT and join a rover team over here, a team Anveshak, then I mean, obviously we have a social media handle. You can try and follow that. It's on Instagram right now. We put in different updates over there. You can come to our orientations when we recruit every other semester. Is there? And in case of all the technical stuff you need to know, there's again, like there's a different verticals that we have right now. Like if you want, I can go into detail right now into exactly what it is if you really want to know. So
We'll keep it simple as of now. Just maybe you can tell about the verticals. Maybe one liner, that should be fine.
yeah, I can do that. So there is obviously a mechanical vertical that we actually call it like a module. So there's a mechanical module right now, and that obviously looks into how to make the rover, the different stresses it can take, the design of it, the whole thing. Then there's the electronics and software module, which looks into how to control, how to give different electrical systems to different components, how to make the motors actually roll in one way, go in one way, how to maneuver the rover from different points, and also how to properly autonomously navigate the rover. The rover has to have like a mind of its own in certain competitions, especially the ISRO competition that's coming up, IROC. Basically what it has to do is behave as much as possible like a human, with a set of eyes and a hand and a pair of legs, just walking around, avoiding obstacles and craters, and picking up a particular object, dropping it in a bin. We do that via localization. Like it's a fancy term, but it's basically being aware of your surroundings. That's what we do. There is also an astrobiology module that we have, that's basically looking into how we can detect life at different paths. And one thing I actually want to say that I'm really proud of the team for doing right now, we have an onboard spectrometer, and usually it will cost lakhs of rupees in the market. So, and we obviously don't have the money to fund that. We're poor. What can you do? So, yeah, student troubles. What can we do about that? So, what we actually did was we made our own using an open source software also, and the cost was driven on very, very significant, about 10-15K as compared to a couple of lakhs. That's something I'm really proud of. And finally, the business and media module, reaching out, different sponsorships, all of that is there. So these are the four things. If any of you are interested in this one, then you can join. They're all like they're all based on the application though, so you're going to do well on that. And also join the orientation and follow the Instagram page.
Actually, none of us had the idea when we first decided to join the team. So it's just you starting to research on stuff. Fill out the app. Once you get selected into the team, you probably have to like research on your own. Learn how to design stuff. Like there's various softwares, you learn how to design them. So once you get used to the softwares, you start innovating stuff. So for now, we have like a planetary cycloidal gearbox, which has like a 95% efficiency and a weight of just 1 kilo, which is pretty impressive compared to the normal gears which we use. So once you start designing it, you'll start innovating. Uh, it doesn't mean that you need to have previous knowledge to get into any other team as well.
Okay. So that's kind of done from my side. If you guys want to interact, I'll be open to it. If you have any questions, you guys have any questions or something over there?
Did you guys apply to the IDEX challenge? Because there was a similar, for the robotic arm, there was a challenge that was floated. You applied? You have applied.
We have applied for that.
Okay.
One question for you, like what is your drone made of? Like what material?
The materials, right?
Yeah.
So carbon fiber. So basically, like if you look at it, right now, all planes either have an alloy of aluminum which they use. If you look at these Airbus A320 news, it's all aluminum, and the other drones are also using metal work because they were manufactured at scale in 2010s. But right now, we need to look at that as well. But for us, right now, as me as a company, we are a small lean team, and we don't have the expertise of metal working. We don't have the time to do R&D, and we found out that carbon fiber is way better. It's way easier to work with, and you can reduce the weight of the plane like by 60-70%, eliminating a lot of metal parts which are not needed, which saves my time in CNC milling and all of that stuff. And it's cheaper as well. Like if we are manufacturing it in house, we want to mold it in house, so we'll have a monocoque kind of design. It monocoque throughout the body, but in the wing we'll have a lot of struts and a lot of structural elements. But majorly, yeah, that's where civil comes into play. But yeah, majorly the fuselage will be the one taking all of the stress, and that's going to be of carbon fiber, and that makes life simple for us. It gives us a lot of internal volume as well. It makes it light as well. We can have some vibration dampening because we'll be using an IC engine. A lot of the decisions come into play because of that. So we'll be using carbon fiber primarily.
Okay, so building upon that, I mean, I have a pretty little knowledge about that. You guys also need to build a drone with the rover as a eyes or something. So, I mean,
I actually interesting point. You guys, the Varun was the head 1 or 2 years back, right? I don't. Yeah, 1 year back. 1 year back. Yeah. So you had a problem statement where you had to fly a drone between two poles, and like it had to go. You had an Aruko marker, and I don't know if you guys were part of the team then, but yeah, well, you guys weren't, I guess. But yeah, I
We
had
weren't
worked with the
actually.
team at that time, with them and helped them build the quadcopter and tested it out for them. Did the PID tuning for them. I had done that. I remember. Yeah, we have worked together before.
I mean, like in the competitions we have right now, it's not exactly very necessary for a drone to be there. I mean, it'd be a cool plus, but there's no proper necessity. Like we're kind of, for preparing for the actual competition, we're kind of backed up on all the stuff we need to do. So adding a drone, if we had time, we'd be really happy to do it. But as I know, the main constraint is more or less just time. So there are specific drone challenges along with the rover challenges, like they're affiliated together. But yeah, we don't actually go out of our way to make a drone. Like we could if we had the time, but we don't. So we don't.
So just one question out of random. Right now, what is the kind of budget that you are having, and if you wanted to make an actual rover, so what is the amount of money that you think would be necessary? I mean, it's a very vague question, but still. So how much X is that as of now?
So as of now, the budget that has been calculated for the entirety of the rover team for this particular tenure has been about possibly, I think, about 10 lakhs or something, so close to that.
Close to that.
So and the other question, if we were to be given like maybe a blank check,
Yeah.
giving like exactly what we need to make one proper rover, I mean, how much money is there in the world?
Okay. Fine. Start the conversation as you were doing. It's fine.
Okay, so you just said that you're gonna make it out of carbon fiber.
Yeah.
But when you operate it at like Mach 6 or 7, it's gonna get overheated, right?
Yeah.
Possibly melt.
It'll burn.
Yeah. So how
Yeah.
do you overcome it?
So basically, that is where like our materials engineering will come into play. Rather than using carbon fiber as a standalone, like if you go to the market and ask for carbon fiber sheets, you'll get this carbon fiber infused with standard resin, which can't go over 150 degrees Celsius. But when you're going at supersonic and probably hypersonic as well, post Mach 5, the temperatures outside, you'll firstly, if you're flying above in like 60,000 feet, you'll have plasma around you. So that will be like half the temperature of the temperature surface of the sun. So it will reach those crazy temperatures. So at that point, what we'll be doing at that scale, the product we'll be building will have a different design from what we have right now. Now, a short-term goal is to have a medium altitude long endurance UAV, and for that we'll be using carbon fiber. But from that, once we have a market and we have a business set out over there, that's when we go to this ambitious project where we'll be using carbon fiber and metals, infusing them with each other because we want the best properties of carbon fiber, but also the ability of metals to hold temperature and even reflect them, radiate them. So at that point, if you look at F-35, the materials engineering that is insane. It can fly, it can maneuver, and it also is made of composites. So and it also goes supersonic. It flies at Mach 3, if I am not wrong. Mach 2, yeah, Mach 2. So in that range, again, it's again flying not on metals, composites. So that's where the engineering will come into play. But yeah, that is an ambitious goal which you have. That's carbon fiber will be used in the short term one, the drones which you are building. I said right, 2 meter, 4 meter, and 10 meters. These will not fly at supersonic speeds. These are just plain the one. This is just to replace our need for importing stuff. Once we have stopped that import and we have the technology to build a whole drone infrastructure, whole drone stack in India, then we can look at these ambitious projects where we have the foundation set. We know how to build a plane, then why not build a supersonic plane? Go that way.
So you guys are building it for spying or like
Combat,
combat?
defense. And we will put it there because the end use case will be determined by our user. We'll have the capabilities, we will not bank on it. We in the drones which we are building right now, we do have hard points where you can mount the payload which you have, or we can custom build payload for you as well. Again, like there are a lot of applications in loitering ammunition where you can have a smaller drone. Like the drones which we build will fly at 35,000 feet. From 35,000 feet, you can have these loitering ammunition drones, which will fall off from our drone, fly at 5,000 feet, loiter around. See, if you know Switchblade, which is like launched, or javelin missiles, which are launched from shoulder. We can have something like that, but dropped from the sky and have loiter around. And if you need to recover it, you can recover it. Else, it can kamikaze kind. We can have a lot of those integrations into our drone. That is what we want to work on.
So this Avishkar Hyperloop evolved into this Jupiter Hyperloop as a startup, right? I mean, it evolved in terms of not the same guys, but the idea at least evolved into a startup, at least in the IITM Madras ecosystem. So any plans similarly with the Anveshak thing? Like, are you guys taking this idea forward as a startup? Maybe for, I don't know, asteroid mining or, and there are companies who are doing similar kind of work.
There has been some conversation about it, and we have been approached by a few people. Right now, the plans aren't exactly coming together very well because mostly because students have their own commitments. But yes, we have considered it, and it could very well be a possibility in the future. Fields like mining, agriculture, like as of now, only on the Earth because it's not stable enough to send into space. It is a prototype after all. Even the electronics are not going to work properly. Silicon-based electronics won't work at those temperatures in space. So yeah, it is a possibility, and I can see it happening in the future. But right now, it's not a major concern. I do believe like it should happen. I am all for it. It's just that the time is not right.
So one question I had is like you are doing for ISRO or maybe space exploration, you are doing for defense, you're doing for more of like manufacturing and over that. So as a whole India, I'll say, what is your vision about like okay what India should be looking like in some days according to your areas? Some because like for example I'll state a answer over there like defense. So you kind of answered over there that India should be ready by 20 years. For you, what is the Indian perspective of it?
So to answer this question from my context,
Yeah.
I'll give you a quote which was said by APJ Abdul Kalam when they asked him, "Why are you building these weapons?" He said, "Strength respects strength." So
Mm-hmm.
if you have strength, and also there was this one quote I read by Anduril, that company which builds, they said, "Fight, have an unfair advantage." So when you have an unfair advantage, that means you're technologically superior.
Mm-hmm.
You will have like India as a whole. Right now, we are looking at like a renaissance in manufacturing. A lot of people are talking about it. A lot of interest is being shown. We have already had, customer-based startups, which like Ather.
Hmm.
They started building scooters. They started from a battery stack, and now they're building scooters and like their own Ather stack. They've built a supercharger network. Something like that should happen, but in these critical domains
Hmm.
where defense is very important, space is very important. We
Hmm.
know attacks can happen from space. You know that we need to have information about what happening elsewhere, that how is it done by lower LEO satellites and all of that. So like this entire sector as a whole holds a lot of strategic importance, and the only way we can, like India can just the Viksit Bharat aim
Hmm.
is we have to have power here,
Hmm.
build for this, indigenize it, build it in house, then we can say we can go to the world and show that we have the capability, and we can't be intimidated by anyone. That is the end. That's what this whole geopolitics is about. You
Correct.
know why does America has like a 20-30 year old lead over everyone?
Hmm.
Because they have been working on this technology from 1940s. They went to the moon. They're the only country to go to the moon. How now that gives them the bragging rights because they have the capability to build, and that led them to be like the single polar, power center in the world.
Right.
So now it's breaking up.
Mm-hmm.
Things are gonna move about. So
Fine, let's not deep dive into it.
yeah,
Yeah, so
yeah, but yeah,
maybe
that's what.
yeah.
So with respect to our thing, so we are looking at a global customer this thing. So we are seeing a gold rush, you can call it as a gold rush for what is called as microgravity, taking advantage of the microgravity environment in orbit.
Mm-hmm.
And the low-hanging fruit in that is in the areas of life sciences and material sciences. That is
Okay.
the first thing. Those are the first
Mm-hmm.
markers that is coming to it. So in this gold rush, we are positioning ourselves as the guys who sells shovels instead of doing the actual digging. So
Okay.
we will be just for be the facilitators in this gold rush. So
Correct.
similar to AI and NVIDIA,
Mhm.
NVIDIA taking the money.
He wants to be NVIDIA of space.
Yeah, we
Yeah.
want to be the facilitators for this gold rush. That is one thing. So in terms of, and India also already and always has a brand image in the space sector. So in that respect, we want to keep that lead in that, and we want to do something. We are doing something that even ISRO has not tried out.
Yeah.
So this is something that we have to take the lead. That okay, private companies, we are not just followers. We have to take the lead in the global space itself. Like we just this kind of a mission is actually not being thought about, whatever we are doing it in this scale of operation. So we want to take the lead in that.
Okay, so one of the questions to you. So, as being in IITM, so how did IITM specifically impacted your life, as in life? Then you come to Anveshak. So, how how do you feel it would be have been different if you were not in the team or something like that?
So what we study here is what we do in Anveshak. So for example, I can say we had like manufacturing processes this semester. So we learned a lot about additive manufacturing, but you cannot really learn how to do additive manufacturing unless you actually do it. So C5 comp teams are like a way to exercise that. You get to learn all sort of manufacturing processes as well as electronics as well. So if I was not in IITM, I wouldn't have got funds to do this. See, if I was not there, I wouldn't have learned how to do that in real life.
And
Basically, the exact same as what he said, along with the you missing out on the actual experience of working in a team, being a part of something, enjoying everyone else's company. Like, yeah, basically what he said, but other stuff included.
okay. Okay. So similar question to you as well. How did IITM affected your life? Like you said, you were pretty much into about drones and stuff in your childhood as well. But how did IITM affected your life? Then you got incubated in Nirmaan. So how did that affect you?
Yeah, I mean the infrastructure here, the support system, the people you meet here. Like the if you look at anyone in C5, everyone's working on something. Like the com teams are working on these ambitious goals, and like when when the peer group around you is so good, and then when you have infrastructure set up like Nirman, I would say it has been very pivotal. And like if I was somewhere else, I would have to worry about a place to work out of, the funds for it, how to run a team. Here, everything's set up, and it's just for us. It's a playground for us to come and use, and that is, I would say, the best thing for an engineering student who wants to do something. And we
Okay.
have something like this. It's a dream.
Mm-hmm. Great. Okay. Similar to you, you have been in IITM from maybe how many years?
Past 10 years.
Past 10 years. So yeah,
So,
it clearly says.
Yeah, so the idea, as I said, happened only because we are associated with the lab in the IITM. Because we dropped our this thing, and then also I'm a PhD student of Professor Satya Chakravarti. So in the same lab, this is the same lab where Agnikul, Galaxy, and currently E-plane is happening. So seeing them actually evolve from like having like figuring out what to do and then going much bigger. So that also actually had played a role in this journey, you can say that. So if I could say like if there's one person who influenced me, it's Professor Satya Chakravarti.
Okay, great. For this episode, I guess. And thank you guys for watching the video. Hope you guys like, share, and subscribe. And yeah, if you guys want to add anything for the viewers, you may.
We have said our part.
Okay, great. Anything? Okay. Fair enough. Thanks. Thanks a lot for watching.